Hi, my name is Ray Poynter, and I want to talk to you about the benefits of conjoint analysis and choice modelling. In traditional research, we might try to address questions like, how important is screen size compared with size of memory when buying a laptop? But that's a really difficult question. Is it 2.5 times, 3 times? It's very hard to put a context. How much extra would you pay for 24-hour service, either in the context of PC support or in terms of room service or whatever? Or we see these sort of questions. On a scale of 1 to 5, how much does each of the following drive your choice of holiday? Number of tour reps, transfer time, number of swimming pools, number of nightclubs. The problem is, this is not the way our brains work. There's a lot of investigation going on at the moment about the relationship between the emotional part of the brain and the rational part of the brain. Damasio terms it that we're not a thinking animal with a feeling brain. We are a feeling animal with a thinking brain. And so we need to get that balance right. And I particularly like the description that Chip and Dan Heath have got in their new book, Switch, where they talk about the elephant and the rider. The elephant is the emotional part of decision making. It is the vast majority of what happens, and most of the time the elephant goes where the elephant wants to go. The rider is the rational bit. Yes, the rider can do a little bit of organizing, a little bit of thinking, a little bit of ration, but it's a much smaller part of the whole process. And if we want to understand decision making, we really need to make the surveys and the processes appeal to the elephant much more than the rider. So here's a very simple example. I want to understand how much you like colors and shapes. So here's my first respondent. And they say, okay, 1, 2, 3 across the top, 4, 5, 6 across the bottom. And we can see, looking at this data, that this person prefers triangles. And they prefer green to red and red to blue. But the difference between the triangles is more important than the difference between the colors. All the respondent had to do was simply rank those. They didn't have to try to put structure to that thinking. Here's another respondent. What can we see going on here? Well, this respondent prefers green. That's the most important thing. Then red, then blue. Within that difference, they then prefer triangles to squares. So again, this respondent hasn't had to put any values to how much they prefer red compared with blue, as opposed to triangle versus square. We can imply that from the answers they give us. One final example of that. What have we got this time? Well, we've got a respondent who prefers green. After that, they prefer triangles to squares. And within that, they prefer red to blue. So we've got quite a complex pattern of preferences going on here. But again, it becomes immediately apparent. All the respondents had to do is look at those and say, well, I prefer that one to that one to that one to that one. And we can work out what's going on. Now, how do we do that, working out what's going on underneath these choices? What we do is we turn them back into a regression equation. So if we take the first row of that equation there, we've got that green was offered, red wasn't offered, blue wasn't offered, that's why it's got a 0. Triangle was offered, that's why it's got a 1. Square was not offered, so that means it's the green triangle, the one in the top left. It scores a rank of 1. And all of those pieces go together to make an equation which we can put into the right form of regression. Now, some of you might be thinking, wait a minute, we don't actually need as many columns as that because of dummy variables. If you're thinking of dummy coding, then you don't really need an introduction, and you can join in the Q&A in a few minutes. The language of conjoint and choice modeling is very precise and very informative for us. We have attributes. So in this study of our triangles and squares and colors, there are 2 attributes. The first attribute is color, and the second attribute is shape. Within color, we have 3 levels. There's the green level, the red level, and the blue level. And within shape, we have 2 levels, triangle and square. And taking that last respondent, what we see is that they value the part worth, or the utility of green, is really high. And this is on some standardized data coming out of those choices. It's worth 109 points. Red is only worth 18 and blue is worth 0. triangle is worth 73, and square is worth 0. With those 5 numbers, I can work out the preference this person would put to any combination of red, blue and green with triangle and square. And I will get back to the choices they made initially. Importance in choice modeling and in conjoint is the difference between the best thing you can do on a level, on an attribute, and the worst thing you can do on an attribute. So in color, the best thing you can offer is green. That's worth 109 utility points. The worst thing you can offer is blue, which is 0, and the difference between them is 109. Within shape, triangle gets 73 utility points, square is 0, so the importance of the attribute shape is 73, which tells us that color is more important than shape by 109 to 73. And if you think back to that slide, it was the color ones that were picked first. And that's how we link these simple decisions, appealing to the elephant, show people some choices, let them choose the ones that they would naturally choose, rather than trying to get the respondents to use the rider in answering that. Now, how do we collect that data? Well, the oldest, most traditional way of doing it was the card sort. Cards were produced, different combinations of the attributes and the levels were put on those, and people simply went through and they sorted them. And that had got some advantages, it had some real disadvantages. It's quite easy to sort the ones you like at the top. It's not too difficult to sort the ones you hate into the ones you hate the most. But there tends to be a whole bunch in the middle where you don't really hate them, you don't really like them, and you're pretty indifferent to which order you put them in. It can be very tedious if there's more than a small number of cards, and it doesn't work very well online. We have ratings conjoint where I show one card at a time and you give me a scale 1 to 5, 1 to 7, 1 to 11, whatever that scale may be on how likely you are to buy it. The problem is then we're going back towards the rider rather than the elephant, because this is a rationalized concept. What is the percentage chance you would buy it? Sometimes people do some clever things with stars and crosses. Other people do things where you're allocating chips, but they all run the risk of going back into this rider territory. The one the psychometricians really like is the paired concept test. So I show you 2 and say, which is you more likely to buy? Show you another 2, which of these are you more likely to buy? And that's great, except it gives you really, really small amounts of data. It's also the first one of these, which is discrete choice. You are picking one and you're rejecting the others. That's what we mean by discrete choice. It's much more like what people do when they actually buy. When you go into the supermarket, you don't rate the cans of beans, you buy one. You don't rate the different cars, you buy one when you go in to purchase a car. So discrete choice is much more like the real purchase situation. The vast majority of choice modeling is done through this sort of discrete choice where a number of options, it might be 3, 4, 5, it might be 10, are shown across the page. You might have a none of these options, allowing people to drop out. And that's a discrete choice. So we're collecting all this choice data and we're trying to appeal as much as we can to the elephant and not to the rider in collecting that information. Why do we use this conjoint and choice modeling information? Well, we like to do what-if modeling. If a client has got 2 plans and they want to know which is the best plan, well, there are much better methods of doing it than going into choice modeling and conjoint. But if they've got a very wide range of possible options, then what-if modeling, allowing them to look at different scenarios and to optimize the outcomes, is a really good way to go about it. We can also do what's called a needs-based segmentation. If we identify that some people are motivated by speed and some people are motivated by price and some people are motivated by convenience, we can, through our choice modeling or conjoint, we can then segment them and find out what are the right sort of products to offer this market. Maybe we're trying to determine what are the drivers and the importances within a market. Maybe we're trying to put dollar prices against those. Maybe we're trying to work out overall prices. So all of those sorts of studies tend to use conjoint and discrete choice modeling. Also, what else we're doing? New product development, thinking now in terms of projects as opposed to techniques. new project development, portfolio management. You've got a wide range of products. Can you reduce some from the marketplace? Where are the holes? Simple pricing research, scheduling offers. Now that might be menu offers within a fast food restaurant. It might be options for programs within a plane. It might be types of journeys. All sorts of things can be scheduled and offers. It can also be used as the input to customer satisfaction. Once you know what is driving customer satisfaction, you can then weight the scores that come back from that customer satisfaction to optimize the outcomes. There are some significant limitations, and we need to be aware of those. One is the number of attributes. As the number of attributes grow, then the cards become very complex. It's difficult to understand what's going on. It's very hard for the respondent to do the tasks, and we start to end up with very sparse matrices. So we try to keep the number of attributes in conjoint and choice modeling down to a small number. There are some ways of getting around that, but really it's nice if they are 4, 5, 6, and 7, not 20 or 30. Attribute interactions. Both conjoint and discrete choice modeling assume that we can add together the benefits of the different attributes, but that's not true if they interact. Let's think for a moment about drinks and about temperature. I like coffee, I like hot coffee, and I quite like cold coffee. Tea, I don't like hot tea and I don't like cold tea. So that works quite fine. I can see how that would fit into a choice modeling. Then we get to beer. I like cold beer, but I don't like hot beer. And so all of a sudden we've got an interaction. Hot coffee can be good because I like coffee and I like hot, but it doesn't work for beer. That's an attribute interaction. So that's one type of problem. Also, if the perception of the attributes varies by people, then it's very hard to do a realistic modeling. So for example, in customer satisfaction, you sometimes get things like fast service, cheerful service. But you and I might differ in what we think is fast service. So even if the conjoint comes back and it says what you really need to offer is fast, or what you really need to offer is personalized service, it hasn't told us enough about what you actually need to offer, because there are variations in how we perceive that attribute. Conjoint and choice work much better with attributes like red, green, blue, 4-door, 2-door, petrol versus diesel, these sorts of issues. Another limitation of choice modeling and conjoint in general is it tends to cost more as an exercise. Typically, I will tell a client it's going to cost you 2.5 to 3 times as much as a standard survey. It's going to take longer to design it, and it's going to take longer to analyze it. So those have got cost implications. Some people will tell you that conjoint and discrete choice modeling create very boring surveys. That's often true, but it's not necessary. You can do these studies so that they are interesting. If you're asking the right respondents about the right questions and you're doing a sensible number of questions, you can make a really fun survey, particularly if it's adaptive. But on the other hand, a great many of these surveys are boring. We can move on from simple level choice modeling, and we can perhaps cover some of those within the questions. We can have attribute specific levels with discrete choice modeling. So if we were doing a transport study, the bus component might talk about the price and the regularity of buses. The cycling component might talk about how much of the route had cycling lanes. The car component might talk about the cost of fuel and the cost of parking. So we can have different attributes and different levels for different attributes. Partial profiles is one of the things that people do when you have too many attributes. So what you do is you just show people a few of the attributes at a time. You need to be careful with this. This is used far more often than it should be used. It will often distort the findings, so be careful. If you have too many attributes, I would say look at something like either adaptive conjoint analysis or adaptive choice-based conjoint, depending on whether you want to do a conjoint or a discrete choice modeling. Those are better ways to go than just using partial profiles. Latent class is another way. If you've not got enough data per respondent to get a solution, you can use latent class to tell you how many underlying clusters there really are and what the values for those clusters are. And of course, the most exciting development to come on the scene in the last 10 or 15 years has been hierarchical Bayes, which allows us to estimate what the utilities of people would have been if we'd asked them 3 or 4 times as many questions. There are some caveats. It does require a good understanding of what you're doing, but it opens up a wide range of new possibilities. So I would warmly encourage you that when you have got the right sort of study, consider a conjoint study, consider a discrete choice modeling study, and let's find out what the elephant thinks rather than what the rider thinks in terms of choice modeling. So thank you very much, and I look forward to questions.